Hey guys, this is Professor Janacek, and I want to tell you about line integrals of vector fields. We'll begin by letting f be a vector field that is continuous on a region that contains a smooth parameterized curve, which we'll call C. Also, remember that t is the notation for the unit tangent vector at each point of C. Now the line integral of f along the path C is simply denoted as the line integral of f dot t ds. Now, computationally, how are we going to work this out? Turns out that this line integral of f dot t ds can be written as the regular integral of f dot. Now recall that the unit tangent vector is r prime over the magnitude of r prime, and then ds, the differential of the arc length, is actually the magnitude of r prime dt. Now notice we can reduce the magnitude of r prime and we end up with f dotted with simply r prime dt. Furthermore, our vector field f, if we denote that as f1, f2, f3 for its components, and r is the vector x, y, z, then notice we can actually rewrite this as the regular integral from a to b of the dot product gives us f1 x prime plus f2 y prime plus f3 z prime dt. Now I want to make note that if I take dt with x prime, that's just dx, and y prime dt is dy, and z prime dt is dz. So we can actually change the notation a bit to, again, this is just a convention. I'm writing it as the line integral of f1 dx plus f2 dy plus f3 dz. Again, just a convention for notation. But if I put together dx, dy, dz, and notice that I'm adding the product of those components, I can actually rewrite that as f dot dr. Again, this is still using the line integral notation. So that's an integral along a line is what we're looking at. I can change it now to a regular integral of f evaluated at r dotted with r prime dt. So let's try an example here. Let's take a look at the line integral. Again, it's an integral along a curve of f dotted with t for f being the vector field negative yx, and we're going to look at this along the semicircle. R is equal to 4 cosine t, 4 sine t, for t going from 0 to pi. Notice that this is a semicircle, so t goes just up to pi, not all the way around to 2 pi. Okay, so a few things to make note of. First off, we have, of course, that r is equal to 4 cosine t, that's a vector, 4 cosine t, 4 sine t. So r prime will be negative 4 sine t, 4 cosine t. Also, f is negative yx. Remember, the x and the y values come from r. So f ends up being negative 4 sine t, comma 4 cosine t. So if we want to evaluate this line integral, Again, this tells us what we're actually going to do is, so that's again an integral along a line. We're going to change it to a regular integral of f dotted with r prime dt. So that gives us the integral from 0 to pi of, now I'm simply going to take the dot product of f with r prime. So that gives us negative 4 sine t times negative 4 sine t plus 4 cosine t times 4 cosine t. And we're going to integrate with respect to t. Oh, well, isn't this nice? This gives us 16 sine squared t plus 16 cosine squared t dt, which is just, factor out that 16, we just get 16 dt, which if we integrate that 16t evaluated from 0 to pi, which gives us simply 16 pi. Well, that wasn't so bad. Again, writing these line integrals, I'm taking the integral along a line, simply rewrite it as a regular integral where our integrand is f dot r prime. Not too bad. Enjoy.